Hello viewer, welcome to my channel Learn Physics.
व्यूअर्स, आज इस वीडियो में हम साइलैब में एक प्रोग्राम लिखेंगे टू सॉल्व सिस्टम ऑफ नॉन होमोजेनियस linear equations using Gauss Seidel method. Consider n non-homogeneous linear equations as given below. Coefficients of x1, x2, x3, xn on left-hand side of above equations are written as matrix A, also known as coefficient matrix, and right-hand side is written as column matrix C. One of the conditions to ensure convergence of Gauss Seidel method is condition of diagonal dominance. Also, all diagonal elements must be non-zero. To understand diagonal dominance, let us consider a system of three non-homogeneous linear equations. Above equations can be written in matrix form representation as below, where A, X, and C represents corresponding matrices. Diagonal dominance. Diagonal dominance implies that in matrix A, absolute value of diagonal element must be greater than or equal to sum of absolute value of remaining elements of corresponding row. Here inequality should be there for at least one equation. Above condition can be rewritten as: if this condition is satisfied, then initial approximation x1, x2, and x3 converge to exact solution. In case of n equations, condition for diagonal dominance takes form as given below. Let us now proceed towards understanding Gauss Seidel method. For sake of simplicity, again consider three non-homogeneous linear equations. We have already seen these equations. Consider initial values of x1, x2, and x3. Then from equation 1 and using x2 and x3, we have new value of x1 denoted by x1 prime. Now from equation 2 and using x1 prime and x3, we have new value of x2 denoted by x2 prime. And similarly from equation 3 and using x1 prime and x2 prime, we have new value of x3 denoted by x3 prime. This gives rise to new values of x1, x2, and x3, and this process is repeated till fixed number of iterations or till values with desired accuracy are obtained. New values of x can be written in compact form as follows. For n equations, above statement takes form as given below. Let us take one example. First, check the condition of diagonal dominance. For equation 1, it is true. For equation 2, it is true. And for equation 3, it is true. So we can say the condition of diagonal dominance is satisfied. Now proceed to solve the set of equations. Consider initial value of x1 equal to 0, x2 equal to 0, and x3 equal to 0. For first iteration, from equation 1 using x2 and x3, we have new value of x1 denoted by x1 prime. From equation 2 using x1 prime and x3, we have new value of x2 denoted by x2 prime. And similarly from equation 3 using x1 prime and x2 prime, we have new value of x3 denoted by x3 prime. Now new set of x1, x2, and x3 is there. Now let's go for the second iteration. From first iteration, we have x1, x2, and x3. From equation 1 using x2 and x3, new value of x1 denoted by x1 prime can be calculated as follows. From equation 2 using x1 prime and x3, we have new value of x2 denoted by x2 prime. And similarly from equation 3 using x1 prime and x2 prime, we have new value of x3 denoted by x3 prime. So now we have new set of x1, x2, and x3, and so on. While attempting to solve a set of non-homogeneous linear equations, a situation may arise where diagonal dominance is not satisfied. In such case, sequence of equations may be rearranged to check if diagonal dominance is satisfied or not. Consider following example. Here condition of diagonal dominance is not satisfied. If for such set of equations, condition of diagonal dominance is satisfied by merely rearranging the sequence of equations, then Gauss Seidel method can be applied. Here condition of diagonal dominance is now satisfied, so Gauss Seidel method can be applied. Viewers, in some cases, it is possible that no condition of convergence is satisfied, but still Gauss Seidel method may give exact solution. तो चलिए Scilab में प्रोग्रामिंग शुरू करते हैं। तो चलिए viewers, प्रोग्रामिंग स्टार्ट करते हैं। We have already defined matrix A and C. Now we define the augmented matrix T is equal to square bracket में लिखेंगे A, C. We display this matrix D, डबल कोट्स में लिखेंगे augmented matrix. Execute the code. Now we write n is equal to length of C. We initialize the x variable with 0. X is equal to zeros 1 comma n. We start a for loop for k. K is the number of iterations equal to 1 to 1. We start another for loop. I is equal to 1 to n. S is equal to 0. Another for loop for j. J is equal to 1 to n. Here we write a if condition. If I not equal to j, then now we write s is equal to s plus a I comma j multiplied by xj. Here we write xi is equal to d I comma n plus 1 minus s divided by d I comma I. Here we write display number of iterations डबल कोट्स, दो बार प्लस का साइन, स्ट्रिंग k. Now we write for I is equal to 1 to n mprintf backslash n x percentage d is equal to percentage 2.4f comma I comma x I. Now we execute the code. So after first iteration, we have values of x1, x2 and x3. We can further increase the number of iteration from 1 to 2. Execute the code. Number of iteration equal to 2. And now we have slightly modified values of x1, x2 and x3. Similarly, we can have 5 iterations. Now instead of having fixed number of iterations, we can have concept of accuracy in our variables x1, x2 and x3. For that purpose, we need to modify this code. We say E is equal to 1, accuracy is equal to 0.01, K is equal to 0, while E is greater than accuracy, Y is equal to X, and K is equal to K plus 1. And here we write E is equal to abs Y minus X. Now we execute the code. You can see that we have an accuracy of 0.01 in our variables x1, x2, x3 with 3 iterations. We can enhance the accuracy up to 4th place, and we see that just by merely running the code for 5 times, we can have accuracy of 0.0001 in x1, x2 and x3. So this is how, viewers, we can use Gauss Seidel method in Scilab to solve a set of non-homogeneous linear equations.
व्यूअर्स, आज के वीडियो में इतना ही। उम्मीद करता हूँ कि वीडियो आपके लिए हेल्पफुल रहेगा। थैंक्स फॉर वॉचिंग दिस वीडियो। प्लीज़ वीडियो को लाइक कीजिए, शेयर कीजिए और मेरे चैनल लर्न फिजिक्स को सब्सक्राइब कीजिए। थैंक यू।